Hi, Ashley. Long time no see. Dear friends, all of you watching this, I'm taking this off because I invited Ashley to have a discussion with me, and I'll try to introduce that right away, why we're doing this. I started off wearing a mask. The reason neither of us is wearing one is we're sitting outside, we're enjoying the fresh air, and we're both vaccinated. Twice. So we should be all right, Ashley.
Definitely.
We should be all right. So why are we here? And I'm changing the role around now. I invited Ashley, and Ashley, thanks very much for accepting.
Very welcome.
And the reason for doing that is, as you know, there's been on social media a lot of talk about vaccinations, about whether it's an experiment or not, whether it's real or not, whether it helps or not, whether, etc. But there's one in particular which we want to focus on today, and that's something that was circulating first among our colleagues in St. Martin, but also here in Curaçao, which is from a Belgian virologist, Geert van den Bosse, a PhD, worked in the vaccination pharmaca, I should say, is an independent researcher, at least he presents himself as such. And he's using certain arguments that seem to resound within our scientific community as well. So I thought it appropriate, because he is a virologist, he's saying some things, he's asserting some facts, and I thought who better to give comments on that as our own respected immunologist. You are an expert on the area of clinical immunology. The assertions are made on the area of immunology. So it seems appropriate that somebody who knows something about the defense mechanism in our bodies, that we explore what is being said and try to determine what is truth and what is maybe not so okay. So therefore this, because it doesn't seem to be all right if somebody is going around saying all these things and making people scared, even making our colleagues and scientists scared, while nobody is even placing questions as to the validity of the remarks being made. So again, thanks very much for joining me.
You're very welcome.
And let's see how far we can get with this, and how can we understand what this Dr. van den Bosse is saying, and if there's any validity in what's going on.
Mm-hmm.
So bear with me, because I will go with you through some of the things that he says, and some of them might be repetitive, but let's see where we can go with this. So one central thesis, one general rule that also van den Bosse places is that virus replication on a background of suboptimal immune response enables immune escape of highly mutable viruses.
Mm-hmm. Mm-hmm.
That's one of his general theses.
Okay.
He also says prophylactic vaccines should be administered for 3 reasons. What they do is they ensure full-fledged protection, or you give it to prevent exacerbation, as what you would do in Ebola, for example, etc. And they prevent immune escape and hence enhance infectiousness or even resistance to the vaccine.
That's a very strange combination.
Because?
Let me tell you about that. Because viral mutation is not microbial mutation. So viral mutation is in the essence reproduction of the virus in a population. And by reproducing in a population, it mutates. It doesn't mutate within one organism or one person. So the concept of viral mutation with immune response is the fact that the virus gets different hosts, and through those different hosts, it mutates. And then, by chance, it becomes resistant to an immune response. So how do you tackle that? You tackle that by eliminating the capacity for the virus to mutate in a population. Hence, you need to vaccinate. The moment you have an effective vaccine program, you remove the chance for the virus to keep replicating, to keep reproducing, and hence you remove the chance for mutation. And that's the fact, that's a fact. So in a sense, that doesn't compute with what he's mentioning, because it's just the other way around.
Hold on. Let's get into that, because now it's a total contradiction to what Geert van den Bos is saying, right? Because again, now I'm playing devil's advocate here, as you know. This is a weird role for me, by the way, being the interviewer for once in my life. But so I'm not doing this very well. So let's see where we go. Van den Bos seems to say exactly what you say, the opposite, right? He asserts that the vaccines that we're using today are safe on an individual basis, but not on a population basis for populations exposed to the pandemic. He's asserting that the vaccines are effective on an individual basis, but not for populations that have been exposed to a pandemic. Now that seems like a conundrum to me. So it is safe for individuals, but if you vaccine a lot of individuals together, suddenly it's not safe anymore. You just said something about that, but do you mind to comment on this?
Well, I think it's very strange, because by getting resistance in one individual person, you're actually contributing to the herd immunity at the end. So everybody is contributing, and at the end you eliminate the virus because the fact that the virus can't replicate. So it's a simple formula. Next to that, there's another point I want to put forward, is the fact that there is pressure on the virus, and what he mentions is like the vaccine is putting pressure on the virus. Whereas that's not true. The virus is constantly under pressure because we have been, as humans, very effective against the virus. Remember, 85% of persons actually, in a very mild way or even asymptomatic, remove the virus in, 2 weeks' time eventually? So there is pressure on the virus, be it a vaccine or be it our normal immune response. So there's no difference. So again, showing that that vaccine only helps to get more people resistant at a certain moment in time. Whereas if you let the normal way go, so you get normally infected, at the end, it'll result, of course, in a complete, let's say, protection, but in that way, you're choosing for more deaths. So that's the only difference. There's not an extra pressure, because those viruses we have right now, with all the mutations we know, from the British mutation, South African mutation, 2 mutations in the United States, 1 in Brazil, most of them we've described before starting vaccination programs. So viruses, that's the thing they do. They mutate, and by chance, they have a mutation that makes them more effective. But again, it makes them more effective, so we need to remove them out of the population and not letting them keep on replicating. So again, it's not the same as he's saying, and again, that pressure is already here. So the only thing is the vaccine helps us by not becoming sick and removing as fast as possible. Lastly, we know from the Swedish experiment, when this all started, where Sweden, as one of the very specific countries, chose not to have measures, not let everybody be infected in a natural way. And the result we have right now is that Sweden is not an example on how the situation should be. Right. It's a disaster, actually.
There's actually an example closer to home.
Which is Brazil, of course. Brazil.
Especially Manaus.
Especially Manaus, with about, 70% of protection in October last year? And if you go back to Manaus...
76. Actually.
Even 76. So if you go back to Manaus right now, you see that that herd immunity wasn't even enough. And that was herd immunity without vaccination.
Right.
So again, and what we know now from Brazil is, what's their coverage? About 2%. So it just serves to show that that doesn't work. And again, it serves to show with real data, so not only experiments, that what that gentleman is saying is not according to the data we are seeing right now.
Okay, I'll get back to this issue again about death rates. We have something to say about that as well. And the reason for wanting to come back to that is there's still people saying, well, look, what's the big deal? It's a flu. It's not worse than a flu. It's the same thing. So let's try to explore that a little bit later on. But I just want to go through some of the things that Geert is still saying, or Van den Bosch. I don't know him personally, so sorry about the first
Mr.
name
Van der
basis.
Bos.
Yes, Dr. Van den Bosch.
Whatever.
The reason for doing this is that because he is a scientist, he's coming out with these things, and that resounds with people. So I think you seriously need to look at what it is and why isn't anybody contradicting this? This is for me a conundrum. So one of the things that he's saying is, again, coming back to, you said it earlier anyway, but so what is the truth in this? He's saying all of the vaccines are inducing specific antibodies to the S protein. So none of them prevents viral replication. So he's saying if the antibodies are like too low in concentration or have too low affinity, they won't prevent any replication, or they prevent replication. And he comes to the conclusion that they cannot control replication of more infectious coronavirus variants and may even drive immune escape.
Excellent.
Now let's talk about immune escape, and please explain for all of us non-immunologists around here what he means by innate immunity.
Well, innate immunity is the immunity you have at the beginning. So that's immunity that through cells actually, so no antibodies, or maybe a low level of IgM antibodies. That's the immune system you have at the moment you see the virus first. So there's no memory, there's no experience with the virus. That's what we call the innate immunity. So it's actually your first barrier of defense. You have that already. Every one of us has that. And that's the first line of protection. But the way it works is that the innate immunity is the first line of protection while you're making actually your second line of protection, which is more effective, which is like the cavalry coming in. So that innate immunity is your first line, which we already explained. So the first time the virus comes in, that's the immunity you actually have. So those are cells, those are cytokines that start up the mechanism for getting a more effective immunity in. So but that innate immunity is also very important. So when you have a full-fledged immune response, you have your innate immunity that works well, and you have your what we call your humoral immunity. So your innate immunity is actually based on cells, and your humoral immunity is based on fluid circulating antibodies actually. But what he forgets to mention, if you have a very effective immune response, you have the best of both worlds. So you have T cells who are actually the orchestrators of the whole immune response, so the director of the program, and you have circulating antibodies. Those are protective. But those antibodies are actually made by other type of cells, which we call B cells. But those B cells already are directed by the T cells. So to make it short, if you have an effective immune response, you don't only look at antibodies. You especially look at T cells, because those are the ones that are directing your immune response. Your antibodies can wane over a period of time, right? They can be less effective over a period of time, but it is your T cells that actually make the difference. So if we're only concentrating on antibodies, we're only concentrating on a certain part of your immune response. Whereas if we look at the T cells, and we know now from research that those T cells are very effective for all kinds of mutations we're seeing right now. And these are results we're seeing from persons who were infected and recovered. So again, going back to that part, antibodies actually block the virus from getting in. But the moment the virus gets in, then the T cells actually take over, because they protect you of any sequelae or becoming very sick. So that's why also we now are seeing that a lot of those vaccines are very effective, in a sense that not only people do not, after a second shot, become infected, but the ones that do become infected do not become really sick. Well, that's because of the innate immunity. That's because of the T cells. But again, a lot of it's referenced to mutations. And I need to say, when you have an immune response against a spike protein, it's what we call a polyclonal immune response. So it's not just one antibody. What he's referring to, and we've seen that also with these mutations, is the fact that when you use what we call a passive immunization, either convalescent plasma or monoclonal antibodies, those are very specific antibodies. And literature and research has shown that through mutations, a very specific monoclonal antibody, so just one antibody against a very specific epitope on the S protein, can fail. But in a normal immune response and through vaccination, you get a polyclonal. So you get all kinds of antibodies against that spike protein. So by eliminating the capacity of one antibody to bind, you're not, of course, eliminating the capacity of all the other antibodies. And what we're seeing also right now from studies is, for instance, that the Pfizer vaccine results in antibodies, polyclonal antibodies, that can be protective or block viral entry against all of those mutants at this moment in time. But again, I'm not even saying, I'm only saying antibodies. We're doing now some research on those T cells because it's more difficult to analyze those T cells. So a lot of people just look at antibodies. And when we look at those T cells, and now we're talking about persons who have been infected, their T cells are very active, and their T cells are active against all of those viruses. Why? Because they're especially active at the moment the virus gets into the cell. So the whole spike protein thing has already taken place. So their reactivity is against the whole virus. So that combination through a vaccine is what you're getting.
Okay, so let me try in layman's terms, because you listed a couple of very important points. One is Mr. van den Bos's theory is actually based for a very large part solely on antibodies.
Exactly.
And on the fact that he says that antibodies are waning.
Right, which is normal.
And his supposition that waning antibodies means that you are more susceptible. That is not true.
That is not true. The moment antibodies can wane, or levels can wane. But the moment your immune system gets in touch again with a virus, it'll reactivate. That's the memory we get. The memory we get are B cells and T cells ready to go. The amount of antibodies you have, and this is not only for the COVID vaccine, it's for all types of vaccine we know. If you look at their antibody levels in persons that have been vaccinated, it wanes. But the moment you see the virus, that's the nice part of the immune system, it kicks in. And the interesting part also is that what we know, and of course we're trying to see that also with the SARS-CoV-2 infection, is that we also see affinity maturation. And what's affinity maturation? It's the fact that when the virus has preliminarily been eliminated, and in most viruses there's still some remnant antigen in your immune system. And that remnant antigen is not the virus, it's just part of the virus, it's a part of a protein or whatever it is. And its task is in the immune system to keep on stimulating your immune response to even make your antibodies and your T cell response better. So in the second or the third time, and that's what we call affinity maturation. So the first line antibodies you produce are even geared up to better recognize in the second and the third time they see the virus. So it changes a little bit. The antibody, the binding of the antibody changes because we are looking at different combinations of antibodies. And that's what we call affinity maturation. So your response even after that is even better than the second time. So the third time or the fourth time, you're even better off. And sometimes we need to have that affinity maturation with a second or a third shot. We know from different viruses that you need to revaccinate after a couple of times because of the fact that you need to re-trigger the immune system. But the antibodies you get back are affinity maturated antibodies that are even better. So we're delving into that at this moment in time because we need to acknowledge the fact that we've known this virus for what? A year and a half? So we're still learning a lot, but the concepts he's referring to, those basics concepts, are not our weakness. It's more or less our strength of our immune system.
There's another part in this where he refers to. So again, here's a certain assertion that he asserts or attributes a special role to so-called naturally asymptomatic carriers.
Right.
And what he exactly means by that is not quite clear. Would you care to venture, because he asserts he then gives him a special role, implying that asymptomatic individuals are carriers and keep on infecting others for life, I'm supposed to assume. I'm not aware of anything that shows us in that direction. That's number one. And number two, again, his buildup of his thesis is solely based on the fact that there are antibodies and that they're waning. He is not covering the entire immune system.
No.
That's basically, in a nutshell, what you also just tried to explain.
Exactly.
Very difficult, but clear.
Yeah.
Thanks.
Okay.
But coming back, have you any information about these naturally asymptomatic carriers?
Well, what we know, that in the information, there are either two things that come to mind. The first one is, of course, persons who get infected and are asymptomatic carriers, but that disappears the moment they remove the virus. So you have a normal immune response, you're asymptomatic, but afterwards you have removed the virus, so you're not infecting anybody more, right? There is an example we know of long-term carriers that keep producing virus, because you need to produce complete virus, so not viral particles. You need to produce complete virus to be infective, right? So there are certain persons who are immune deficient that get treatment with either passive immunization with plasma that are so immune deficient that their immune system cannot remove the virus. So, but those are on a very individual basis, and maybe one or two patients exist we've described with this. So they're immune deficient, they can't remove the virus, so the virus keeps reproducing, but that's the amount of those patients is very, very low. And that's more anecdotal than having an impact on the population, because we all know them, they're in the hospital, they have bone marrow transplants, things like that, and they get infected and they can't remove the virus, and they can't remove the virus with even with passive immunization. So that's one example, but that doesn't have any impact on the whole population.
Let me just take a venture outside, just to latch on to what you just said. There seems to be some confusion or some thinking amongst also doctors, specialists, that if you are immunocompromised or if you're using immunosuppressives, you should not be vaccinated. I would think those are the people that actually need.
They need as soon as possible to be vaccinated, because of the fact that when they get the virus, the consequences can be very deleterious to their health. So the thing is, of course, if you're immune suppressed, you get vaccinated, you get protection. The only thing we are not quite sure of is the fact that how strong that protection is. But it doesn't weigh off against being protected, because it's the same immune system that's weak that doesn't remove the virus when it meets you heads on. So any help you can get with a vaccination will eventually help you against the infection. So again, people who are immune compromised or having immune suppressive drugs, they need to get vaccinated ASAP.
In other words, better some protection than zero protection.
Better some protection, and that some protection can be, of course, very effective. That's what we know.
Let's carry on with the other issues that are being raised by Dr. van den Bossen. It seems that the postulation is this, something like this, that because we're already seeing mutations, variants of concern, that are acting more severe or that are more infectious, that there's being made a link with suppressing your innate immunity
Aha.
because of vaccination.
Mm-hmm.
So there's one issue. Well, we just talked about that it's the other way around, possibly.
Exactly.
So because mutations are taking place already, and you said it earlier, mutations have been taking place a long time before we even started vaccinating.
Exactly. That's what
And
a virus does. It mutates.
Yes, and it's a natural course of the virus because they're looking for a more efficient mode to transmit.
Well, it's a selection by chance. Viruses replicate without quite a very good control on how the replication goes.
Right.
So it's by chance that something else comes up that's even better than before, and then that will have an advantage in reproduction, but it's completely by chance.
Yeah.
And that's mainly the part why you need to eliminate that by vaccinating.
But let's get back, because Van den Bos is particularly worried in the long term, because he's saying basically what we're doing by vaccinating during a pandemic is creating a monster virus that will hamper and kill our future generations. Now that seems to be contradictory to what we know about mutations and why viruses mutate. And
And vaccination, of course.
yes, and one simple question to you. For as far as you know, can viruses mutate endlessly?
No, no. What we know right now is the fact that viruses, we think, and research shows that it's what we call convergent evolution in a very complicated or nice sounding word. That means that the virus has only certain mutations it can make use of. For instance, if we're talking about the spike virus, that spike needs to bind to the ACE2 receptor, right? So there are a lot of mutations that result in the fact that that spike cannot bind. There are a lot of mutations that are not effective, so they are actually eliminated. And there are a couple of them that enhance that binding. But there's only a couple of them. They can't go on forever. We know where it takes place. So that's what we call convergent evolution. And what you see, and that's very interesting, with convergent evolution, you see the same mutation starting in different places of the world. So now we have a mutation in the Philippines, which we will probably call the Philippine mutation, but it's actually comparable to the Brazilian mutation. And when we look at the Brazilian mutation, there are some mutations in the virus that's also present in the British one. So again, showing that it's a process by chance. And there's a limited amount of places that mutation can take place, which as a result makes the virus viable. So again, that's not the case. And I want to reiterate the fact that vaccination is infection simulation. So what we're doing with a vaccine is actually simulating a viral infection without making that person sick. So when you're saying, well, you don't want to vaccinate in a pandemic, the next thing, which is the same, is you get infected. So that same infection is like a vaccination.
Yes.
And going back to what he's saying also in the fact, well, you know what, it's just one protein and that's in a sense. So that's also one of the aspects that a lot of critics are telling about this vaccine of Pfizer, which is only one, and what he said also, so it's only one spike protein. Let's make use of the conventional vaccines, which are the vaccines made of whole viruses, you know, attenuated viruses, things like that. So you get a whole virus, so you get the whole immune response against the whole virus, which is much more effective. We now know that the Sinopharm vaccines in China are made in this old-fashioned, very effective way. So they're attenuated viruses, whereas the one of Pfizer is messenger RNA virus, right? But if we look at the effectivity of the Sinopharm vaccines, and we know that from Chile and from Peru, they've been using that, against, for instance, the Brazilian mutation, it's only 40 to 50%, whereas the Pfizer vaccine is much higher. So again, it's showing that all of these concepts relate to basic immune response. And the nice thing of the immune response is, again, it's humoral, cellular, innate, and developed. So that makes the whole story. And if you're just focusing on one part, of course, you see waning antibodies. And of course you see mutations. But again, for that mutation, I think it's very powerful for everybody to realize what a vaccine does. It only simulates. So you either get infected or you get your vaccine. And this is what we're also seeing in the program right now. We're seeing by research that persons who have already been infected have a certain level of protection. So they actually don't need 2 shots of the Pfizer vaccine. They only need 1 shot because actually they've got their first shot already by being infected. So again, it serves to show that the whole concept is as we are saying and not as that Mr. Van den Bossam is referring to.
There are 2 additional things, if I may. About the assertion of Dr. Van den Bossam that the idea that you will be creating a super contagious, terrible monster virus. Just tell me if correct me if I'm wrong. My understanding of mutations is such that the virus needs to find ways of enabling the species to survive.
Exactly.
And viruses, in general, need human bodies to survive.
Definitely.
So it will be contrary and counterproductive to the viruses to kill us.
Of course.
Is that correct?
That's absolutely correct.
Thanks very much. Because if the virus is the drive for evolution to keep the species alive, it would be totally counterproductive to kill us.
Of course.
So the idea of creating a monster virus doesn't really sound very resilient. That's one issue. The second thing I wanted to, you mentioned it already, but you mentioned the Brazil variant. I want to ask you specifically because there's talk about that maybe the vaccine would be resistant against the South African variant.
The vaccine would be resistant,
or the
not effective. You mean?
Not
or
effective.
Okay.
But there is new research that's showing us maybe in the direction that maybe that would also not be completely right, or is that, do we have?
Well, there are some data now coming in of persons who have been infected actually, and what we see, there are 2 things. We are seeing before the vaccine, we are seeing people who have been infected by the South African variant. They're now showing that they have a much broader resistance. Their antibodies block all the variants actually. So these are preliminary results, but very encouraging, showing the fact that, of course, we need to understand that a virus and the immune system are in constant interaction with each other. Learning as the virus mutates, the immune system also has more capabilities. So that's one part. Secondly, for the vaccines themselves, there have been this week published figures by Pfizer on their vaccine, showing that the effectivity of their vaccine holds true also for the South African variant, so for persons being infected. Because again, we need to show, or we need to realize that from these studies, some of them are lab studies. So we're actually looking at the effectivity of antibodies to block infecting cells. Whereas these studies like Pfizer, they're just looking at the outcome. So they're looking at persons in South Africa. They had about 900 persons in South Africa that were vaccinated. And what they saw is that the effectivity of 92%, they're seeing that also in South African variants, or persons infected with South African variants. And next to that, the ones that do become infected don't become extremely sick. So again, very hopeful, 900 against the bigger amount in the United States they were looking at, but very encouraging.
Besides not becoming very sick, that seems to be correlated with the amount of virus load.
Exactly.
That you have, viral load that you will build up, even if you do get infected after being vaccinated, right?
Yeah.
Which also translates into less probability of you affecting others.
Absolutely, absolutely. Those are figures we know. We've been seeing that, and that correlation comes from other studies like in Spain. There are a couple of publications showing how important the viral load is in order to be effective in transmission. So it's very important to keep that viral load very, very low.
Even though worldwide we've vaccinated millions of people in the meantime, and that there's an increasing amount of evidence coming out from studies being done, continuously. Um, s- Still and all, there are also groups of professionals saying don't take this vaccine because it's an experiment.
Right.
It's an experiment.
Uh-huh.
Would you mind to comment on how experimental this actually is? Because I'm not sure if we've ever been able to gather this much information ongoingly during this mass vaccination because of the pandemic going on and the willingness to vaccinate people that actually leads to much more information than we would have ever had in another circumstance.
Definitely. This is, of course, a very exceptional situation we're in. So the frame of mind needs to change because of the fact that, as we already discussed, we know this virus for about a year and a half. So we started vaccinating in November last year. So those figures keep coming in. And what they're actually referring to is, of course, the emergency approval those vaccines get, for instance, by the FDA. Now, to be very honest, they get that emergency in a sense when it's in a certain experimental phase. This for vaccines actually refers to the fact that vaccines get their definite approval by the FDA after they've shown that vaccine to be effective after 6 months use. Now you need to put that in balance with the fact that the effect that the virus has on their community was such an extreme effect that it was chosen to give them an emergency approval and not wait for those 6 months from the first 45,000 they described in the original scientific papers. So now that has been reached. This week, Pfizer has sent all its data to FDA to get the official approval. So in a sense, making use of the fact that it needs a very specific approval, it's between brackets a kind of experiment. But looking at all the figures, looking at the more than 150 million people vaccinated in the United States, looking at the whole population of Israel, that's showing a tremendous effect of vaccination because they're the ones that started in, November, December? So they have already about 70 to 80% of their, actually 70% of their population vaccinated. And you see the effectivity. You see in every day that the amount of persons being effective is declining. But let's not only look at that for vaccination. Let's take the opposite. We already mentioned Brazil with 2% not vaccinating, not doing anything, and it's a total disaster. So if you call that an experiment, fine by me. It's a very good experiment. And that technical experiment for Pfizer is finished because we're now, after 6 months, they're going to get their official approval. And getting that official approval and saving such a huge amount of money, I mean, it's a no-brainer.
People will say, some people are saying, all right, fine. It works on the short term. But what are the long-term effects?
Yes.
Look at Geert van den Bossen.
Yes, right. So what we would expect long-term, hopefully, is that we're being protected without a second or a third or a fourth shot. So that's what we expect. There is no information from any other source or any other publication by using vaccines that there are any secondary effects long-term than not the immune system being capable of removing the virus. That's from all other kinds of studies we've done on vaccines. So by experience, we know that. So we're not expecting anything else. And people need to realize one thing. It's very important. I've discussed that a lot of times. A vaccine is not a drug. A vaccine is a natural product that the only thing it does, it'll boost your immune system. It's like an infection. So if Mr. Van den Bos is worried about the long-term effects, he should be also worried about the long-term effects of the viral infection. It's the same. So I don't see that as a major issue. Again, going back to the fact that what's in a vaccine, that message RNA is removed in 2 days' time. And all the other products within a week. So there's nothing over and circulating in your body than your immune system. And again, I think this is a very powerful argument because the virus does the same. So if he's worried about the long-term effects of the vaccine, he should be worried in the same way with the long-term effects of the virus.
So let's again repeat for those who think differently. The mRNA technique that's being used now of introducing that in your body is not incorporated in your bodily DNA.
Absolutely
and
not.
does not stay longer in your body than a couple of days.
No, 2 days, actually a couple of hours it's removed. That's why we need to store it at minus 80. Because the moment it gets to body temperature, it's stabilized a little bit because of the vaccine, but then it gets automatically removed through a natural way. We remove RNAs all the time. We get infected all the time. So all of them are natural mechanisms. And again, if we're worried about a vaccine, we should be worried about the virus also.
Clear. Just to end off, let's leave Mr. van den Bossche.
Absolutely.
I think we said enough about that. Like in concluding, we're saying what you're getting from him is a totally incomplete picture of how the immune system works.
Exactly.
And using very partial,
very fragmented, yes.
Very fragmented information that's not quite coincidental with reality in terms of what it means for the effectivity of a vaccine, or what it means for the danger in the future, and what it means for mutations or killer cells that are going to be made later on, etc. And is not giving a complete picture of how the immune system actually works.
No, he's actually describing the very important basic procedures and mechanisms that actually lead to a very effective immune system.
Exactly.
But he's turning it the other way around, which is completely not true.
Yes. So therefore, the importance of an immunologist to tell us about the system. Two other issues, just to wrap this part up, because there are, again, persistent ideas about this epidemic, this virus, being no more harmful than the flu, and that the percentages that we see are not any different from any flu season. My answer to that, but who am I, would be...
You're the epidemiologist, you should know.
My answer to that is that, and you showed me this evidence earlier today, that what we know now of evidence coming forth from the United States and elsewhere is that your mortality caused by COVID-19 very clearly took a hit upwards.
Exactly.
And very clearly is last year is the third cause of death.
Yeah.
Even corrected for other variables, is the third cause of death in the United States.
There's a 20% increment compared to 2019.
Yes, which is not normal for any given flu season in the past 100 years.
No. And the pattern is completely different. So you see the pattern is actually correlates with the outbreak of COVID-19 in the United States. So you know it better than I know.
Yes, but also for those saying that, so it does have a harder impact. We know it does affect mortality now, but also, and I'm forgive my question, but have you ever heard of a flu season that takes more than a year?
Not on this planet.
There you go. So for those of you still doubting and saying that this is a mere flu season,
no,
it's not. I have never seen a flu season in the past whenever.
And have we seen our hospital in this state?
This is the last thing I was going to get at. A hospital admission rate that we're seeing now in Curaçao, right now, and the enormous increase on the short term of young people being affected, having oxygen need in a rapid tempo, seeing the increase of deaths going up steeply in a very short period of time. In Curaçao, our rates in the normal flu, we've never seen this. Never, ever.
Of course not.
And this is taking a year, and we're seeing this. So for all of you doubters out there, I hope we have been able to contribute something.
I just want to add something that comes to mind also, which makes a difference between the vaccine and the viral infection, because I was stressing a lot on the fact that they're comparable.
It's the same.
It's the same. There's one difference. And if we're talking about long-term sequelae, right? So what we know right now is the fact that when you get infected with a virus, through all of the fact that there is something going on with your body and you have to go to the hospital and there are a lot of complications. We now know that 30% of persons who get infected actually have sequelae, so they have long-term COVID. They have problems with their lungs, they have problems with their cognition, they have problems with their hearts, and that's an effect of a sequelae or an effect of the virus, long-term.
Right.
So that's the virus, and that's not a vaccine.
All the more reason.
So better get the vaccine than the virus.
All the more reason to get vaccinated. All the more reason to support vaccination strategies, and all the more reason to try to vaccinate your population as quick as possible so we can get this over with. So we can move on to some more normal kind of terms.
Yes.
Please stick to the facts. I hope we've been able to take some doubts away and clear some issues up that also scientists are producing that are not covering the entire story. Thanks very much, Ashley.
It's been a pleasure.
And maybe we do this again, but we turn around the roles.
Absolutely.
No, I like this better.
That's fine.
Thanks very much.
You're welcome.